So in R, the kmeans function is the function that we use to implement the kmeans algorithm here. And I can demonstrate it here using a simple data frame. I got with just 2 dimensions, and I called kmeans on the data frame, and I tell it there are 3 centers, all right, so 3 centroids. And what kmeans returns is a list with a number of different elements in it. And so, for example, probably the most important element is the cluster element. And you can see here when I print out the cluster element, you can see that it's a vector of numbers from 1 to 3. So, and what this shows is for each data point in the data frame that I passed it, it tells me which cluster it's in. So you can see that the first 4 points are in cluster 3, the next 4 are in cluster 1, and the next 4 are in cluster 2. You can see another element, if you look in the printout of the names, another element of the object returned from kmeans is called centers, and this tells you the location of the centroids in the space. So if you want to plot the results from kmeans, the first thing you can do is you run the kmeans algorithm on your data. And here I'm just going to plot the data. So the first thing I do is I plot the data. So I plot x, y, and then I color the data points according to the cluster that they happen to be in. So you can see that I pass the call argument to be equal to the cluster number. And then I use the points function to kind of add the centers, the cluster centroids, to the plot, and I plot them using the plus symbol. So here I plotted the data and the k-means clustering results. So finally, another way that you can visualize clustering information from an algorithm like k-means is by using the heatmap function, or looking at heat maps, I should say. So here I've using the same data. I take a different random sample of the data set. I sampled with replacement, and I just run k-means again with 3 centers. And I store it in an object called kmeans object 2. And now I'm going to make an image plot of the data. So the first plot on the left here is just an image of the original data. And then on the right-hand side, I've reordered the columns of the data, or sorry, I should say the rows of the data frame, so that the clusters are kind of put together. So here you can see that if you go up and down this matrix, you'll see the data points are clustered together. So that they're next to each other, and so you can use this to look at high-dimensional data and high-dimensional image type data or matrix type data, where you can reorganize the rows and the columns, and kind of look at clusters that are closer together or farther apart, and so look at your kind of matrix data in an organized way, so you can look for patterns. We'll talk a little bit about this more when we talk about hierarchical clusterings, but you can use heat map type of visualizations with other types of clustering algorithms like k-means too. So just to summarize, k-means is a handy algorithm for organizing and looking for patterns in high-dimensional data. A couple of things it requires that you know the number of clusters. So you have to specify, at least roughly speaking, how many clusters there are. You can kind of play with that a little bit to figure out kind of what pattern probably looks the best, but there's no easy rule there. And then so you have to kind of pick those clusters out by eye or through some other mechanism. There are a few algorithms for kind of determining the number of clusters, using cross-validation, information theory, other types of metrics. And so here's a link to determining the number of clusters. And the k-means algorithm is not deterministic, so depending on how it's implemented, there can be sometimes the starting points are chosen at random, and so it's often useful to run the k-means algorithm a couple times just to make sure you're not getting a very unstable finishing point. So, for example, if you run it 3 different times and every time you get a totally different pattern, then that means that the algorithm may not have a very stable kind of view of the data. And so, k-means can be problematic in that way with certain types of data sets. And here I've got a couple of links to kind of to videos and references that provide a lot more information about k-means.